Hello everyone, it's Dylan with the HD Perspective. Got a little bit something different today. So my dad, he was a helicopter engineer for many years, and this is his toolbox that he worked out of. I guess in aviation, they're called engineers. They're not like us mere mortal mechanics. So I don't know if that makes them any better or what, but this is his box. We'll start at the top.
Okay, so most of the work I did was out in the field, so I had a bush box, but this was my rollaway for the typical tools. And as you can see in the top, a vast array of sockets, common to everything, whether it's helicopters, aircraft, heavy-duty equipment. There's sockets, but most of ours are 1/4-inch drive or 3/8 drive. The odd big one, 3/4-inch drive. Sockets have special purposes. They look like they haven't been used, but they've actually seen a lot of use, and these would be used for removing oil pressure sending units, main rotor mast nuts, blade nuts and whatnot. Especially ones we make for out of common sockets, cut them apart and extend them so we get greater depth for certain bolts called latch bolts. So we've got some specialty handmade tools that we will make. So like you can see, it's pretty much a common assortment of sockets, but it's not typical for us to use much above 1/4 or 3/8 drive.
This is mostly metric or standard that you use?
I used mostly standard. There is metric, a lot of French helicopters now, so I do have some French or metric tools. Generally the common tools, but most of mine was metric back in the day.
Yeah.
Adapters to
standard back in the day.
Standard, yeah, standard. And then adapters to go all the way up to 3/4 inch. So from time to time, to get into a tight spot, using one of these sockets to get into a pressure sending unit. This would be stepped up. And, well, it's tight. But there you have, we'd use my 3/8 drive.
So rack. Probably weren't that tight in there then?
No, maybe 70, 80 foot-pounds torque.
Oh, okay.
Not big torques, like no impacts are used, or extremely rare on helicopters. We do have a couple of big torques, but most of the torques upwards of 200 inch-pounds, and then we'll get a few that are up in the 80 to 200 foot-pounds. And then the mast nuts that hold the rotor blades on, those will be upwards of 600 foot-pounds.
Okay.
So generally lighter torques.
Torque multiplier for that then?
Yep. Or a great big snipe on a calibrated torque wrench.
Okay.
Yep, 600 foot-pound torque wrench.
So what else you got here in this top box?
Well, markers, that's not much important. Q-tips, we clean a lot of things with.
Okay.
Assorted punches and drifts. You can see, like, these are aluminum drifts and brass drifts. If we're beating on something to remove it, we don't want to damage it. It's not pig iron. They're pretty fragile. They do the job, but we'll use aluminum and brass drifts quite frequently.
Non-marring.
But we'll just take and use them from a piece of aluminum bar and make it to do whatever we want.
Okay.
This is just an assortment of bearing races and pieces that I'd use for removing bearings, pushing them out. Some split pieces for removing seals in specialty applications. Those are just made as you need them. I think it's just an assortment of miscellaneous stuff.
Yeah, can always
Everybody's
come in
got
handy.
those. Yeah. That's right. This is an assortment of various stones we use for dressing out turbine blades. If there's damage, which sometimes happens, you need very fine stones and very fine reamers. You might do some line reaming of bushings to get things back true again. So just a miscellaneous assortment.
Okay, so if something goes through the turbine engine, that's what...
Something small that doesn't take the engine out, we'll dress compressor blades.
Okay.
And there's axial and centrifugal compressors, so we'll dress the leading edges if it's within limits.
Right.
Yeah, various markers, nothing much there. Bunch of measuring equipment in this one. We still use old story micrometers. Yeah, I don't know if any of you guys even know how to use a micrometer, but yeah, most of it's digital these days. Mine is still the old thumb screw micrometer gauge. 10 power magnifying glass. Geologists use these a lot, but we use them for inspecting parts. Up to 10 power, and we'll do a lot of inspecting using these. Mm-hmm. And vernier calipers. Like I say, a lot of things we do, we'll do checks of wear and tear. And everything we have that checks measurement has a certification tag on it, and they have to be calibrated anywhere from 6 months to 24 months, depending on use. And
so it's, yeah, there's not much room for error.
not a lot, but pretty defined parameters, so we're not really too worried about, exceeding them. Little hole gauges, so you check bearing bores.
Drop that in there and then measure it with your
Micrometer.
Yeah.
Yes, that's pretty common for me to use. And what else do we have in here? Another magnifying glass. More magnifying glasses. I have a bunch of little wear pins. We'll check wear and tear on gears and spaces. These are just locally made out of a piece of stainless steel lock wire. We'll hammer them down to a depth or a dimension, and then I just put an indicator on here, and you can put these between a flat plate and a gear surface to check wear.
So a little bit smaller than a feeler blade or something, but
yeah, and just handier. It's a go-no gauge.
Yeah,
and I do have feeler gauges. I've got a standard set. Goes down to 1 thou, I think, or maybe 2.
Yeah.
Yep, and there's another set in here somewhere that's longer. It might be in another box. So that, like I say, a bunch of measuring equipment that is quite often used.
Okay.
Hammers. Dead blow hammer, non-marring.
Yeah, soft face.
Soft face, right here. You can see they're not very big. Anything big we don't tend to use a lot of. Do use impact drivers once in a while. Things do get seized on, so just a basic impact driver set, and it comes in handy.
You put the bit on the end of that, and then you can hit it with the hammer, and
it's spring loaded.
Yeah,
so
and then it'll kind of twist it off.
Yes, and it comes in handy. Various files, from a heavy rasp down to various round ones. And once again, we'll dress out damaged areas from time to time, whether it's on a skin or whether it's on a... fixed wing guys will use them on their airplanes for propeller damage.
Okay.
Yep. This drawer has some more measuring equipment. We've got a base for dial indicator. We've got a couple bases. And dial indicator, once again, it's got a certification tag on it. We have to get them checked quite regularly. And another Starrett dial indicator, a little smaller one with some adapters.
Cool.
So yeah, a lot of that. Pair of pliers, extra bent needle nose. They just have a place once in a while where it's handy to get at. And various hole saws for cutting out bearings and things or areas. They're not used very often. This is just a piece of aluminum with a bunch of adhesive that's been mixed up. When we mix adhesives and sealants, we'll mix them up. And then you do a test on it. You put things together, and then you leave this sit out and dry and cure. And you'll verify it's cure. There's many layers on here. When I finished working actively, mine was about 4 or 5 inches thick, and then this was the replacement for it. So just do that to confirm that your adhesives have cured fully.
Yep.
Before you
put the unit back into action.
Yeah, and then various drawers, drill bits, standard drill index, numbered drills, standard drills, various attachments, countersink measuring, fairly standard. This drawer, some pliers, twist grip, lock wire pliers we call these. These are good old snap-on.
Yeah, it's something that you probably don't see too much in automotive or heavy duty.
The race car guys will do it. We have lock wire stainless steel. Most of the time we use 032, 32 thou, or 020. So when we're fastening something together, you put it on the bolts through castellated nuts or whatever, and then you'll wire them together, safety wire them. A lot of the high performance race car drivers and stuff, they'll use them. But these pliers, you put it through your hardware and then pull it, and it gives a nice twist.
Cool.
And it makes it really handy to do. You can do it with a standard set of duck bills. When I was an apprentice, my teachers, we were not allowed to use lock wire pliers. We had to use these duck bills. And you can see they've seen a lot of wear and tear over the years. They're pretty worn out. They've made a lot of wire twists. These make it pretty handy, and we're pretty specified in what we're allowed, 8 twists per inch, basically, and we can go between multiples of bolts and hold them together, and there's certain techniques involved, so go through a lot of lock wire.
Yeah, I bet.
That's the pliers. And then the other pliers are pretty common, side cutters.
I guess that's kind of a thing with aviation. Everything's got redundancy built in, so you can't just torque a nut down. It's got to be
Yep.
Lock wired as well.
Yep. Or cotter pin. We do a lot of cotter pin. Junk drawer. Miscellaneous. Set of screw extractors here. Good old Mac tools. I had these since, I don't know, the early 80s. And I've twisted a couple of them, but generally speaking, they would succeed in getting out a seized-in screw or bolt that's broken off. They work far better than the little auger ones I found. Drill a hole and drive these in. And they're common. You guys use these too, I'm sure.
Oh, yeah.
But
I got a set like that. A little newer, but...
Yep. And then, just some miscellaneous. Like I say, most of my work was out of a bush box, so some of these drawers aren't as organized as some of the Snap-on big boxes like yours are. Yeah. I made this tool. Okay. It's for removing bearings out of a rotor head, out of a Bell 206. Rotor head. There's a split line, and there's some bolts that clamp down on a trunnion type bearing, and we put this in, and in the split line, you drive that in, and then right in with a wrench, and it'll expand it a little bit. Pull the bearing out, put the new one in, retract that. Of course, you're doing that with a wrench or a socket, and then take your put your bearing back in, and then put the retaining hardware, a couple of bolts. So I made this just around the shop, and then heat treated everything. It was kind of cool. Cool. So lots of things we'd make just because it's fun to do.
Yeah, well, and probably they got a lot of fancy specialty tools nowadays, but back then maybe they didn't have everything that you needed, or it's cheaper to make your own stuff too sometimes.
Yeah, and it's fun to be creative.
That's right.
The tools are quite expensive to buy specialty tools. Nothing special about these. These are just grease needle fittings for your grease guns. But getting into some bearings is kind of hard sometimes, so we just heat them up with a torch and bend them, and then we can get into the tight spots where some bearings are. Those are something that are locally made. Most bearings, most helicopters, the newer generation helicopters have rubbers, mounts elastomeric bearings, so they don't use a lot of grease. When my generation, and still today, most of the older Bell helicopters, a lot of grease. So we used a lot of grease. Love that stuff. This drawer is kind of a mess. Screwdrivers, basically, and miscellaneous. Inspection mirrors, we do a lot of inspecting. Use a flashlight and typical kind of mirror. So you do a lot of looking backwards. You learn to look backwards. You can work backwards and upside down using a mirror and trying to get into some places. Allen wrenches. Good old Snap-on ratcheting screwdriver. When these came out, they were awesome. We did a lot of twisting before, just by hand, and then Snap-on came out with these. Interesting thing, probably a year after these came on the market, they didn't have the different colored handles, just straight black. And these were, I don't know, $60, $70, maybe $50, I don't remember. And then Lee Valley Tools for $16, $15 and change, pre-GST, came out with pretty much the same one. The only difference was, and it was an improvement, I don't know if it'll be able to be seen, but the Lee Valley tool, the cap has a big recess in it. So you can actually put more tips in the holder portion of the handle compared to the Snap-on one. It's quite a bit lower, and you can't get as many tips in there. So it was actually an improvement. And we were buying these in Edmonton locally, and the Snap-on dealer found out about it. Didn't like that. Reported it to Snap-on headquarters, and they went and talked to Lee Valley Tools, and strangely enough, we couldn't buy them anymore.
Yeah.
But that was not until there was about 150 of them sold around the city center airport, because I bought about 140 of them and sold them to people I knew, and just basically sold them for a cost plus next to nothing. But they're basically the same screwdriver.
Yeah.
But very handy. And of course now they've got nice handles, newer glow handles, and longer shafts. And
there. I got one, and it's pretty well the same, just it's red and black, like the Snap-on colors, I guess.
But, yeah, today's colors.
But
very handy.
The same, yeah.
Way better than...
I like mine.
Yeah. Other things like this is a standard Phillips screwdriver, but good old Snap-on, but, quite a bit longer, almost 24 inches. The reason we'd have that is we could put a ratcheting box end on this, and panel screws that were Phillips heads would get seized into the panel from time to time, and you could lean into them, and I mean lean into them, and put your ratcheting box end on there, and got more torque, and the length of this would put the torque out without stripping the screw.
Oh, that's cool.
So yeah, this has seen a lot of use.
Cool little trick, I guess.
Yep. And other things, mechanical fingers. We do drop hardware once in a while down in hard to reach places, so You'll have the mechanical fingers, which those are pretty common. I think a lot of mechanics.
You call that the hell hole or whatever?
Yeah, hell holes and different access points. Magnets, they come in handy as well. This one expands. It's saved my life a lot of times. Most of the hardware is steel. Some is stainless steel, which isn't magnetic, so then you need that. And then a neat tool that I got. This was a buddy of mine's dad was a surgeon, and he'd do orthoscopic surgery, and they would use these once and throw them away. So he'd bring them to work and sell them to us for $10 a piece. And this has a rotating head if you look down in the end. Got grabbing fingers. You can rotate it. This has been really handy.
Yeah, worth the $10.
Worth the $10 and probably cost the taxpayers $1,000. Anyway, it's kind of a messy drawer. It's not highly organized, but this drawer is an assortment of wrenches. We'll look at my wrenches a little bit later, but I don't use a lot of these anymore because I'm not so much a deal with things like the old school spanners for getting onto nuts that are slotted nuts. I've got a couple of different sizes, so those come in handy. You can see they've seen a lot of wear and tear. Crow feet. We use a lot of crow feet. Changing hydraulic servos in a Bell 212. I was up in the high Arctic, didn't have a set, so I went to work with a hacksaw, a file, and I made a set out of some round plate steel I found. I didn't cut the round, I found it and I cut that. That got me out of a tight spot. Took me about a day and a half to make these, but what else was I going to do? There was no TV to watch back then. Yeah. Of course, I come home and I spent probably 60, 80, $100 a piece on these Snap-on crow feet. I have no idea what they cost now. They're probably way cheaper.
They're up there. No, they're still $70, $80 a piece.
Yeah, so I bought those. So I had the professional ones, various crow feet of different sizes. And then, of course, I went and spent, I don't know, $300 or $400 or more and bought everything from 3/8 up to 1 1/4 inch.
Yeah.
So then they've been used a lot. Crow feet, they come in handy.
Yeah, that's weird. Well, I have them too, but every once in a while you use it. But
yeah, that was the same with us, just once in a while.
Yeah.
Then other tools, fuel controls, adjusting. It's like your fuel injection system, I guess, on a car, or maybe heavy truck. We'd have to do some adjustments. So getting into them was often really tight. So we'd make up a tool, take a little wrench and cut it off, put a pin on a piece of rod, braze it together, and you could pivot in there and get in and do your tweaking adjustments. Obviously not high torque areas.
No, just adjustments.
Yeah. I don't remember what this one was for. It's a 7/32. Probably had to get into the back of an instrument in an instrument panel and couldn't reach it. So anyway, got out some welding rod and heated it up with a torch and cut one of my wrenches apart. And I don't remember specifically that one. And other thing, here's a modified crowfoot, trying to get into a fitting on the back of a fuel control where the regular ones wouldn't fit. So I just sat there and filed away. And then when I got home, I took it to the polisher and cleaned it up a little bit, but spent a lot of time so I could get off one stupid nut. And other ones that are bent to various fit in, sometimes you get a nut that won't fit, that you can't get into, and it's too tight of an area, so bend and grind. You usually try not to do that with Snap-on or Mac ones because they're expensive. So these would be even no make on them. But
whatever cheap wrench you can find.
I have ground a couple Snap-on ones that hurt. And then these kind here are for adjusting fuel nozzles, taking fuel nozzles out of a PT6, I think, Pratt & Whitney turbine engine. And other little box end extensions. You don't buy the whole set, but you got a 9/16 and
those nice torque adapters.
Yep.
Yeah,
so we use them from time to time.
Tight spots.
Pretty cool stuff. Yeah. Okay. Moving down. Well, pliers, miscellaneous. Here's the big stuff. Fix the pilots with this one.
The pilot adjuster.
Pilot adjuster. Anyway, various pliers that come in handy. Snap ring pliers, circlip pliers. They're not used a lot, but when they do, of course, they're very handy. Yep. And generally speaking, we'd buy the Snap-on or Mac. You can see the Blue Point back in the day because they seem to last longer than the cheapy ones. Wire strippers, these have been used a lot. And crimpers, we do some butt splites, common butt splices and whatnot, but anymore today, you've got to have a calibrated tool because they've got a specific shape. But out in the bush, it gets you out of a bind.
Yep.
And these have definitely done that. So an assortment of pliers. Oh, these are interesting. These are called hole finders. When we're riveting structures together, sometimes you got to reach in far and you want to match a hole that you've taken a working rivet out. See, this end will fit into the hole that you've drilled through. And then we can put this reach in and this hole lines up. so that you can actually drill through it.
Oh, that's kind of neat. That could come in handy, yeah.
Oh, yeah. It lines things up in a big distance areas. So I got a couple different sizes of these. Not something you use a lot. This one was obviously professionally made and bought. You can see the blued steel. But this one is just made out of a piece of aluminum and some stainless steel ends on it. And
yeah, did the trick.
Yep. So you make what you need to make. My metric drawer, the rest of the set is in a wrench wrap, which we'll look at later, but you can see there's offsets. Metric crow feet. Didn't use these much, but there were times when they got handy. I just bought them at the same time as I bought the other ones.
Yeah.
Spend lots of money. C-clamp. I made this when I went to tech school in the 70s. Made it out of a piece of flat bar, including the round.
Cool.
Yeah, that was one of the class projects we had to do.
Even the threaded rod? Or?
The threaded rod, yep. Yeah. The only thing that we were given was this rod here to put through and the screw that fit on the end. The rest of it was cut out of a piece of square, was that 1/2-inch bar. And we had to file this down to round and then thread it to fit in there. So yeah, I don't know, a couple week project, I don't know.
Yeah.
But it's seen a lot of use.
Well, it's good that it's actually useful.
Yep. Other tools. This is a backlash tool for a gearbox. I did component overhaul for a number of years, and we'd use this for measuring backlash on the gear pattern. And then just another homemade tool. Landing gear adapters are like a shock absorber. Taking the tops of them off was a pain. We'd use various pliers, but I took this piece of aluminum and made a bar with a couple pieces of drill bit, a set screw holding it in, and then we could take the caps off and actually service the shock strut and change the O-rings and the seals inside and replace the hydraulic fluid. And that was just another one that was made because it was fun to do.
Yep.
These other drawers are just miscellaneous, bigger stuff. Bearing presses for long reaches, pop rivet pliers, engraver. Nothing fancy. This one, our rubber gloves for when we're using solvents. Big syringes, we'll mix up a lot of adhesives and inject them into areas, and so the big syringes come in handy. Miscellaneous hoses, nothing. This one has various pressing tools for removing various bearings and shaft tools.
Is that like a slide hammer or something?
Oh. No. This is a drive shaft off an oil cooler, and actually it's just a project for down the road. And then I have our flaring tool. Interesting enough, most of your flares will be 45-degree flares. I think. I don't know if you even flare lines anymore.
Well, in heavy duty, we mostly use air.
Okay, so with collets. Aviation, you can see 37 degrees. That's the flare. I don't know why they had to go to 37 versus 45.
Said to be different.
So they could be different. And this flaring tool, we made up a lot of our own lines. Well, you won't be able to see it, but it's an eccentric flare. There's not enough light probably, but the flaring tool itself is eccentric, so it rolls around, makes a nice gentle flare.
Oh, okay.
Pretty cool stuff. And probably like a lot of your shop tools, you get tired of worn out, bent up, broken, dirty ones. So you go buy your own.
Yeah,
and
for sure.
Companies take advantage of that. So that's what a lot of these are. I got my own. And like I say, various tools for pressing various bearings together. Just make them out of a piece of aluminum tool. That's obviously a wing tool. And then, let's see. We've seen these. Another tool that I made up, grease couplings. We have splined couplings on some helicopter drive shafts, and it's really hard to get them back together and put the snap ring in the inside. So out in the bush one day, I sacrificed a C-clamp. Obviously, you can see that. Spent a little time with a hacksaw and a file and made this other shape and did a really beautiful job gobbing it together. But needless to say, it works for compressing the face on the coupling. And then and it would hold everything in place against the spring. Then I could put the snap ring in. I made this up in the high Arctic too, because I was getting sick and tired of losing snap rings. Well, you don't lose them, but you got to go hunting for them.
Yeah.
Of course, the lock wire we've already talked about. Clevis with a bolt. This will lift a whole helicopter through the mast nut. There's a hole big enough for this. Put this through, and then you can lift the helicopter up to change landing gear or whatever you might have to do, or just remove a transmission or mast. So everybody just kind of has one of these, or most people. This is an engine. This isn't locally made. This is for lifting an Allison 250 engine out of the airframe. They're about 400 plus shaft horsepower, and they might weigh a couple hundred pounds. Pretty cool.
Yeah.
This is a homemade tool for pressing an oil pump onto a transmission. 3 holes here line up with the transmission, and these pick up on the oil pump pad, and you squeeze it in by threading the nuts on the backside, so you can do it out in the field, change seals and stuff like that. So that's, once again, pretty big overkill, but it's all I had access to, so you go and do it. And obviously I brazed that together instead of welded, but it's all I could find out in the shop. Well, this would have been done out of a garage, a local garage up north somewhere.
Cool.
Yeah, and then moving over to the other shelf here, we'll look at this later.
Oh, okay.
Just a basic multimeter. Now, you guys are all using flukes and whatnot. This one isn't a fluke. Most of the guys today will use fluke. This is an old Radio Shack or Micronta. It was just used for checking things, not for adjusting. We weren't to do an adjustment. It would cost more to calibrate, test this than it was worth. But you take it out, you got your own meter for your resistance, your continuity checks.
Yep.
And we check voltmeters and stuff. I'd do that. And then if we're doing the annual adjustment, which requires certification, you order the fluke from the shop. But I carried this around. Obviously, that's my own case to protect it, and it still works. So this little box, it's just an old fishing tackle box, has miscellaneous drill bits, little ignition wrenches, various little adapters or pieces and little tool things that the guy makes up that he carries in the bush. It's a bush kit, just like I say, to minimize space and take things that you might find handy. And that's about it for that one. So as I said, I'd covered most of my wrenches before. So being out in the bush, knowing where your wrenches are is important. I had this wrench wrap. They were just Coonies. They were professionally made. I've worn this when I'm here out. But of course, offset wrenches, the snap-on ones, were the only ones available at the day. They've been very well used all the way up to 1 inch. Of course, you can get them bigger, and I do have some. The most prized tools in these were the ratcheting box end wrenches. These were, I don't know, $50, $60 a piece in the day, but they've seen a lot of use. Never broken one, never worn them out, but all the way up to 9/16 and used them a lot. And then my box end series, of course, open end wrenches and box end, they're all snap on. I go from, 7/32, I think, all the way up to, I don't think I go up to 1 inch, or do I? 15/16. Yeah, 15/16 is as big as I go. Most of the sizes we'd use are 9/16, 5/8, ½ inch, 7/16, 3/8, quarter. And of course the metric equivalents as well, which I have in another wrap, but same deal.
Cool.
Yeah. So, but not least, on my surface plate here, this is true to 1/10,000th of an inch. Not everybody has those, but I like tools, and not everybody has them, so I do. It's about 80 pounds. Obviously, I don't carry it around in the bush. My torque wrench is 0 to 200, 30 to 200 inch pound snap-on. Calibration sticker once again, so that they're kept calibrated. This has seen a lot of service. It's been a good wrench, snap-on. And then, this one is called, I guess, a spark plug type one because of the flex head, but it went up, or does go up to 85 foot-pounds. And beyond that, it's usually company tools that get into the big ones. Some guys will get a 200 foot-pound torque wrench and carry it. And then my other one I really like is the torque screwdriver. And this will go up to 45 inch pounds and as low as 9 inch pounds. When we're putting in things like windshields, skylights and whatnot, very low torque on the screws. And yes, we do torque screws. This case looks not used very much, and the wrench hasn't been used a ton, but it's only used in the shop. I don't carry it around in the bush. So very light torque and very handy tool. Mac, I don't know if it's any better than anybody else's, but really good little tool.
Did the job.
Did the job. Another tool that was really nice when they came out was these butane soldering irons. This one's a Weller Pyro pen. Back in the day, we were allowed to carry the soldering pen, but no refills for some reason. I don't even know if you can ship these anymore, but these would be in the bottom of your bush box because a lot of times we didn't have generators and things like that out with us. So the electric soldering iron wasn't used. So that was just a handy tool, and it's seen a fair bit of use fixing things. A couple of other little things. People who play hockey might recognize something like this from a hockey stick with a nail bent over for tightening hockey laces. Well, this is a derivative for emergency flotation on helicopters, or we call them pop-out floats. You have to inspect them and you put them back together. It means lacing things up really tight, trying to get them back in. It's like trying to get a tent back in a bag that you bought from Canadian Tire and it doesn't fit in the bag. So you use these and a vacuum cleaner to suck the air out and these to pull hard and tight. Obviously handmade. And just another measuring tools for checking the outside dimensions of blades, things, external calipers. And these are old school tools, but they did the job. We didn't carry these out in the bush with us. This was in the shop. And then turnbuckles. We would use a turnbuckle like these for holding main rotor blades in position on the main rotor head when we were taking things apart to check out main rotor links. The control bars that go up to them, you don't want the blades to rotate too far. There's damage can happen, so you'd fasten these on. And this has been handmade too. You can see the bending on it, but we just go to the local hardware store and buy it and put it together. It's just terror yoke, not a special tool, but it's scrapped. It's lived out its life, and I'm going to make a ceiling fan out of it and a set of blades. That's the gist of the difference between the hover tech perspective and the heavy duty perspective, I guess.
Yeah. Well, thanks for sharing your tools with us. If you like this video, don't forget to hit thumbs up and subscribe for more and leave a comment below.
2 thumbs up.
We'll talk to you in the next one.